Mér langar að tala NoSQL database og ég ætla að byrja á því að sýna ykkur vídeo hérna sem Marty Fowler að tala NoSQL. Þetta á einhverju ráðstefnu. Hann semst að útskýra söguna. Ég held að sé 8 mínútur, við höfum tíma fyrir það. Viljum að því að heyra Marty Fowler tala NoSQL.
And the first part of this is I'm going to talk a little bit about the history of NoSQL databases, because as with many things, to understand why something is the way it is, it's useful to know how on earth it got there in the first place. Now, when I started in the computer industry in the mid-80s, it was just at the point at which relational databases were really coming in and beginning their rise. It's kind of hard to imagine that there was a time without relational databases, but I remember when they were the new hot thing that people were arguing about whether they would be any good or not. And they've brought us many benefits. Obviously, they look at the persistence of our data. They're also very important in the fact that they manage concurrency through transactions. SQL has become a de facto standard language to talking to these databases. It's not entirely standard, but it's standard enough that once you know SQL, you can talk to these different tools. They've also become very important for many organizations for integration and reporting, which, as we'll see, has both its ups and downsides. So SQL databases are a really good thing, but they also have some problems. And the most obvious problem is one that most application developers run into as they're working with them, which is that we assemble structures of objects in memory, often in terms of a kind of a cohesive whole of things, and then in order to save it off to the database, we have to strip out it into bits so that it goes into those individual rows and individual tables. A single logical structure for our user interface and for our processing in memory ends up being splattered across lots and lots of tables. This is referred to as the impedance mismatch problem, right? The fact that we have these very two different models of how to look at things, and the fact that we have to match them causes difficulties. This is what leads to object-relational mapping frameworks and all that kind of stuff. Now, the impedance mismatch problem is sufficiently of an awkward problem that in the mid-90s, people said, well, we think relational databases are going to go away. Object databases are going to come in. That way we can take our in-memory structures and save them directly to disk without any of this mapping between the two. But we know what happened there. We didn't see the object databases. People like me who thought that they were going to be a dominant thing in the future, we were wrong. And you still listen to me. But, oh well. I guess you're easily taken. But we argue endlessly about why it is that object databases didn't actually fulfill that potential. And I think at the heart of it is the fact that SQL databases had become an integration mechanism. That many people integrated different applications through SQL databases. And as a result, that really made it very hard for any other kind of technology to come in. And that led to relational continuing to be dominant right through into the 2000s. So relational had 20 years of complete dominance of certainly the enterprise data space and plenty of other ones as well. I mean, we saw with the science work at the Large Hadron Collider. They didn't really want to use relational databases, but they had to some degree at least. What changed really was the rise of the internet, and particularly sites that have lots and lots of traffic. The big internet sites such as an Amazon or a Google or a Betfair or something of that kind. As you get large amounts of traffic coming into your data, what do? Well, you need to scale things. And the one obvious route is to scale things up, buy bigger boxes. But that approach has problems. It costs a lot, and there are real limits as to how far you can go. So, as I hope you all know, a lot of organizations, most famously Google, use a completely different approach. Lots and lots of little boxes. Just basically CPU motherboards, disks, commodity hardware, all thrown into these massive grids. But here there's an issue for the data storage. SQL was designed to run on those big boxes. Designed to run as a single data node system. It does not work very well with large clusters of little boxes. And several of the big data players understood this. They tried, they attempted. I've talked to several people who have attempted to spread relational databases and run them across clusters. The usual term that comes up in conversation when they describe how they tried to do this was unnatural acts. It's very hard to do. So, a couple of organisations said, we've had enough of this, we need to do something different. And they developed their own data storage systems that were really quite different from relational databases. And they started talking a little bit about them, published papers that talked about what they were up to. And it is this that really inspired a whole new movement of databases, which is the NoSQL movement. Now, it's important at this point to talk a little bit about where this term NoSQL comes from. A lot of people complain about it, quite reasonably, because they say, well, it's a really odd term, trying to define a movement by something it's not. And the origin is really very simple. There was this guy in London, Johan Oscarsson. He'd done a lot of work with Hadoop and things like that. He wanted to have a look. He had to go to a conference in California. He wanted to take a look at all of these various interesting databases that were poking around at the time. And he proposed a meetup, a little meeting where people could discuss ideas. And of course, if you're going to do that in the late 2000s, you absolutely need something that's really, really important. You need a Twitter hashtag. So he asked around, well, what would be a good hashtag? It's got to be short, it's got to be unique, so we can easily sort on it. And a guy came up with the hashtag NoSQL. That's all NoSQL was ever meant to be. A Twitter hashtag to advertise a single meeting, one point in time. The fact that it has now become the name of the whole movement was completely accidental. Nobody thought that was going to be the case. So, this is the way language often goes. It's very unpredictable, fits and starts. So there was a whole bunch of people who turned up to that meeting, by the way. This is the list of people there. That's not what we call the whole set of NoSQL databases since. A lot of databases who weren't at that meeting are now considered part of that NoSQL umbrella. So this inevitably leads you to the question of, well, what is the definition of NoSQL? And this is something I had to kind of think about writing a book about the subject. It's important, if you're going to write a book about something, to define what it is you're writing about. And my conclusion is we cannot define NoSQL databases because of this very odd history. What we can do is we can identify some common characteristics of NoSQL databases. And there's a whole bunch of these. Obviously, NoSQL databases are not relational. It's actually more about non-relational than it is about NoSQL. Obviously, there's a strong leading towards cluster friendliness, the ability to run on large clusters, because that's what the original spark through Google and Amazon came from. But that's not an absolute characteristic. There are some NoSQL databases that aren't really focused around running on clusters. Most of these databases, rather interestingly, are open source. So most of the things we generally call NoSQL databases are open source. There are commercial tools that like to call themselves NoSQL databases, and maybe over time that will become part of that will no longer be a common characteristic, but it is still a common characteristic at the moment. Perhaps most importantly is they're all things that have come out of the 21st century website culture. There are plenty of databases out there going back long before relational databases that do not use SQL or the relational model. But we don't call such things as IMS or MUMPs, for those who've heard of either of those things, NoSQL databases. So that's what I see as the common characteristics.
Okay, þá veit ég hvað NoSQL stendur fyrir, það er Twitter hashtag. En þetta er mjög góður fyrirlestur. Hann talar síðan þessi módel, datamódelin frá unrelated records yfir highly connected data, graph til dæmis eins og það sem Facebook notar, og svo er relational þarna hægra megin, og síðan eru key value og document model sem eru það sem eru helstu. Key value er bara map, string yfir í object, og það getur verið hvað sem þetta object, það getur verið mynd eða dagsetning eða hvað nú er. Engir indexar og ekkert query. Þetta er mjög skrítið, en þetta skalast og þetta virkar. Og það eru ákveðnir Redis er eitthvað sem ég þekki, og svo eru fleiri eins og Voldemort sem er Jabatsi, ef ég man rétt. Key value 1 og hann útskýrir þetta í vídeóinu, þannig að það mjög gott að hlusta á það. Og svo erum við hérna með document store sem eiginlega svona, þetta samt svo svipað. Við erum núna á stað þar sem að menn eru að vinna í þessu ennþá og þetta ekki allt tilbúið. Spurning.
No schema, eða schema-less.
Já.
Það sem lesið NoSQL, það var yfir mótskóla, það var að tala að það ekki no schema, þetta dynamic schema. Það hafa schema, þú getur svissað því út bara frá object-relational mapping.
Já, sem sagt ábendingin að það er dynamic schema, einmitt. Fowler talar implicit schema. Það er talað að þeir hafi þess að setja þetta í gæslæpir. Það er talað að þeir hafi no schema, en þeir hafa samt struktúr. En struktúrun hann bara skilgreindur runtime. Og þetta mjög mismunandi eftir þessum, Mongo mitt nákvæmlega svona. En yfirleitt eru menn með JSON og þetta allt mjög svipað. En allir þessi grunnar eru með sína variasjónir. Þannig að það hugmyndin fræðin svo, það sem punkturinn sem við viljum læra í þessu að það til fleiri mótil heldur en í relational database og síðan til eitt sem heitir table style database sem svona einhvers konar ég þekki þetta ekki en þetta þendar með mjög óstruktúröð gögn eins og Hadoop og fleiri þá ertu með bara keðju af gögnum og þetta hendar mjög vel fyrir til dæmis með bara svona gögn sem eru algjörlega óstruktúröð og svo graph databasear en það þá ertu með network tengsl og þú þarft kannski ekki að gera neitt query en þú ert að vita tengsl og þetta til dæmis eins og eitthvað sem að Facebook og þessi social network myndi nota. Þannig að þessar fjórar tegundir í Fowler-fyrirlestunum heitir þetta eitthvað annað þannig að þetta það sem mínar rannsóknir hafa leitt í ljós. Ég held að þetta sé bara komið. Ég búinn runnin út á tíma, þannig ég ætla ekki að hafa tíman lengri. En punkturinn þessi, það eru til aðrar tegundir af database sem heitir relational databases. Við erum núna á þeim staði í sögu tölvunarfræðinnar að það er svona verið að móta þessa aðrar gagnagrunnas tegundir. Það eru ekki tilbúnar. Nú erum við að skrifa pappírana. Eftir 5 ár þá verður komin eitthvað svona ok, það eru 4 tegundir, þetta eru tegundirnar, allir eru sammála um það. Nú við erum ekki á þeim stað ennþá.